Hey everyone, this is a re-recording of a talk I made at the SWmobile meetup group that I co-run back in December 2022. So yeah, it's really about how I went about. I spent a day learning about Gradle profiling and how I can apply it to the build at the company I was working for at the time. Yeah, so let's get started. I'm also currently looking for work. That's what the hire me thing is all about. Okay, so I think if you're an Android developer, you'll probably this sort of meme will probably be quite familiar to you. So yeah, the day that I sort of spent researching this is all about like trying to improve the Gradle build speed for when developing specifically Android apps, and really this is what I sort of covered. The Gradle profiling library, some test scenarios that I would do to make things to try and make things quicker, and then the analysis of actually did I make it quicker. So this isn't really a talk about how to specifically make your build quicker. Some of the things I did may improve your setup, but really it's about the tools and approach to how to benchmark your builds in Gradle and how to sort of statistically prove that you've made a performance improvement. That's the sort of key answer to this. So the idea is that you can apply this framework to your builds. I need to move my face from this recording. So I had an idea about the how I was going to improve the build speed, but I knew that just putting this in place, implementing it, and just running it once on my my machine, and then creating a PR with the changes was not the correct approach. And with any kind of scientific or anything real thing where you're trying to sort of prove something, same with functionality, and it's all about measuring it and seeing if you've actually made an improvement. How can you know that unless you have a baseline? So that's kind of what we need to do, to make things, to prove we've made an improvement and not just it happened to be quicker the one time we ran it on our machine. So for this, I read up and looked at the Gradle profile tool. This is a official, Gradle tool. It's properly comprehensive, but this is just scratching the surface to run a benchmark, which is effectively running running a particular task several times, and then it spits out some results of that, and then it allows us to do some analysis on those results. That's the key thing that we're using the Gradle profiler for here. It's super easy to install. This is just how you'd install it using Brew for Mac. And as a sort of another tool which I use as part of this. So the Gradle profiler lets us benchmark, and we'll do that in a sec. But also I was curious to how can I target what areas or what tasks within within my standard Gradle process, because for an Android app there's I don't know, maybe 50 tasks as standard. That may be a overestimate, but there'll be certain tasks that you run day in day out. Some of them are super quick, some of them are cacheable, but I wanted to know where to target, so that's where I used the Gradle build scan, and this is another free tool from Gradle. You get a lot of it for free. You just have to be comfortable with your stats being uploaded, your build stats. It's not like your source code or anything. Here's an example that I used using one of my open source libraries. But this tool basically allowed me to, so it'll go through, it'll run the build with profile, with scanning through, and it'll upload the metadata from that, and allow you to drill down in quite a nice sort of graphical interface to sort of pin down, okay, what are the sort of core tasks on the critical path that I'm running sort of consistently. And I really wanted to, target something that was going to make my life day to day easier, and not something that maybe like is a one-off task that maybe on the release process. So this allowed me to target really stuff a task that I would run on a daily basis, and I felt like that would give the best sort of return on investment. In terms of even a small amount of time saved here, based on the number of times it would be run, it would be amplified. Then that would be the key saving. So, like for example, the build scan showed that our Play Store release process was a lengthy task. You had to do a load of stuff as part of that, but actually that's only run like once a month, and so actually whilst I might be able to save a bigger chunk of time, like in seconds or minutes even, actually if you look at it from a month or from a 6 month or a yearly view, actually the amount of time saved isn't that much. As an aside, we did, as a separate to this, we found that we were building the APK twice as part of that, so we were able to sort of tweak the settings in our Gradle publishing task so it reused the APK it had already built. That was time saved. Anyway, so for this we were targeting. I was targeting the assemble production debug, which is just the name of our of the flavor, the build variant effectively that I was using, and this is like a scenario file. So it's like in a pretty standard sort of JSON like format. It's not quite, and this will give us. This is like a scenario file that you can check into source code, and then have it so consistent, so your teammates can run it as well as your CI system as well. So this is just basically telling it what task to run as part of the benchmarking, and also some other setup, like whether the daemon is warmed up or whether it's cold and stuff. For most of us on our development machines, it's going to be already running. Whereas on the CI system, it would be depending on your setup, I guess. For the setup we were using in Bitrise, I think it was a cold setup. That's the setup, and then you literally, to run the profiler is just this simple command. It's really straightforward, and that'll go away and run the build 10 times by default. And this is a sort of output you get, and it spits out these a CSV file and a HTML file. HTML file lets you view it it's a bit nicer presented, but the CSV file is really what you're after. And just a quick note, 10 times isn't really enough to get a proper statistical proof, and we'll cover that in a couple of slides' time with the analysis we do. But yeah, in terms of on my machine and the amount of time I wanted to wait to do this, it felt like a good sort of happy medium between running it, say, 100 times or something. So now we've got our baseline, our benchmark without any changes. Now we're going to look to try and make things faster. And these are things that I'd sort of gathered from talks that I'd been to and Google I/O and things like this. So I knew that something that Google really promote is the fact that later versions of Gradle and the later versions of the Android plugin are faster. They're always optimizing that. So we were a couple of versions behind on both of them. So I thought that upgrading them, it's a really simple thing to do. Should be not involve much regression. I could go ahead and make that change. Also, because we didn't need this Jetfire anymore. So Jetfire, for those who aren't familiar, is an Android build tool that enabled backwards compatibility for third-party libraries. So a little while ago, Google changed the support libraries from being the support package to being Android X, and the package names changed. This was like a massive change, and so Google with their with their sort of, they're quite good for the backwards compatibility and things. You see that on the Android platform itself. but they developed this tool called Jetifier, which would basically it would be part of the build process. Would go in, sort of rename and rewrite like third-party libraries that you're using that hadn't sort of moved across to Android X, if they were still using the old support libraries. But it was a task as part of it's an extra build task. So the idea is, if you don't need it anymore, maybe you could update some libraries and it would and disable it, and it would save some time. Well, that was the theory anyway. So when we're talking about, and this is now we starting to put more like scientific sort of analysis kind of hat on, we frame these kind of experiments in a sense of like a null hypothesis, which is like, this is the baseline, we haven't changed anything, and then this alternative hypothesis, which in our case is that one of these experiments, we disable Jetifier, we run the benchmark again, and then we compare them. So written in the way. So for experiment 1, this was to do with updating Gradle and the Android Gradle plugin. So the null hypothesis that it has no improvement, and then the H1 that the alternative hypothesis is that it demonstrates a decrease in build time. So we go, we make the changes. For this, it was fairly simple. We would run the benchmark again, and then now we have to go and analyze these. So we have two benchmark CSV files. So we've got two files. We want to compare these results and see if there's any kind of correlation, a decrease in time. And this is where it gets. This is the statistical analysis part, and this is where it gets. I've cut this down for the purposes of this talk. I didn't want to get too. I was trying to keep it light. Essentially, we're looking for statistical significance between these two sets of mean averages, and there's a set sort of formula for this. Specifically as well, this formula is around trying to sort of get a significant analysis when you haven't got enough statistical evidence to sort of to prove it in the sort of more normal way. So this is I should also mention there's a talk by I'm going to butcher his name, but it's from Umberto and Sucess. Sorry if that's wrong, but his talk from Android Summit a few years ago goes over this, and it probably about half. It covers a similar thing in terms of Gradle profiling, but actually spends about half talking about this statistical analysis, which is really useful and really sort of it's done in a very easy to understand way. I didn't want to repeat that here, so I'm just going to refer that for those that are interested, go and check out that talk. It's really good. So essentially, we want to plug these two samples we've got, which is effectively our two benchmark CSV files, groups of results, and then we're going to put it into this T curve, T distribution curve, and use like a paired t-test calculator, which is a set sort of a statistical kind of algorithm which will work out and give us sort of indication on whether there's a correlation. So luckily, we don't have to get our sort of calculators out really, because there is there's a website for that, which is great. So we can put this is the CSV file results, sort of like cut and paste it in, and then we just run the test, and then we'll get the result. And so for us, we had the null hypothesis was that there would be no improvement. The alternative was that there would be demonstrable decrease time, and here's the result from that, from that website. Hitting calculate, it's pretty straightforward. And what is nice is you don't have to really understand all the maths behind it. Just know that this is trying to sort of give you some statistical proof based on the fact you haven't got enough results. And so this is an example of of note, a negative, like there isn't enough correlation in that second benchmark that made any kind of performance improvement. So I went and ran the second experiment, which was to disable Jetafire, and as part of that I upgraded a couple of third-party libraries, and nope, there was no provable improvement with that either. And so I thought, well, why not I try this together, and let's go for both. So this is updating Gradle and disabling. I put Jennifer there. I forgot to change that. Jetafire. Maybe Jennifer is the name of the secret name for the Jetafire tool. But yeah, so yeah, the idea is that both together we'll see if there's a statistical, like, provable decrease in the amount of time. That's what we're trying to do here, isn't it? And this is the result. Yes, so yes, there was a improvement. That's what we can see here with a big arrow. It's saying H0 is rejected. That's the fact that there was no improvement. So we can reject that there's no improvement, and we get a result, so like a 5% improvement, which is great. So like that equates to, I say, when I said 5%, I mean a plus 5% improvement rate over 5%. So here, so it was like 11 seconds off the build time. So roughly 6%. So which isn't, like I say, isn't going to that's not like that much. But I think when you start thinking about this in terms of your day, like the amount of times like a clean build, assemble debug is run, then over time it's a significant saving. So I think, like, I was pleased with that result. I was also able to create these two separate PRs for these improvements, and sort of know that that the changes were provable. Like, together they made a significant reduction in our build time. Plus, also they were good sort of housekeeping things. So yeah, so that's really the sort of the talk. Right, it was a bit of a clickbaity title, but yeah, that's the real win here, as I was kind of like saying initially, is that now I have like a basis, like a know how to go through and create this, these benchmarks. We have a baseline. It's very easy to create. So like one command, we've got run and get the baseline, make the changes, then run it again. So this kind of thing, we can check the scenario file into source code. We can get the CI to run it. We could also run it periodically just to see that we haven't had like a reduction in build speed just over time. I mean, it will get slower, I guess, as we as more code goes into the project, but it can be something that can be reviewed over time and see if there's a particular point at which the build speed significantly increases. So yeah, so I think it was a success. It got me more experience with Gradle Profiler and the build scan tool, and then like I say, a couple of PRs to which were housekeeping PRs anyway, even if they didn't provide a significantly provable improvement, they still were useful things to have done, and so you might be able to make similar changes to your Gradle projects, your Android projects, and save yourself some time. As I say, yeah, the real win is that workflow and the test scenario. It's repeatable, it's shareable, and now when I want to run, I have another idea, or I see a talk on Gradle profiling or speeding up Gradle, I can know how I can do this and run and get some evidence that this is going to make a difference, and also quantify that difference. So yeah. That's really it. As I say, check out that guy's talk if you want to understand more about the maths side. That'll help you if that's sitting that's not sitting sort of with enough detail. Like I wanted to sort of speed through that for the purposes of this shorter talk. But yes, thank you very much for listening. Yeah, thanks very much.